Alright, hi everyone. This video is going to help with section 11.1 in Algebra 2, and it covers permutations and combinations. Alright, so, oops, let me make sure that's as good as it'll get. Alright, looks like it. Okay, so permutations and combinations are how we count different things, and it kind of goes with the probability section because as we need to be able to count different things to figure out the probability. So that's going to be the next couple sections, but we have to start with this so you understand how to count things up. And here's kind of one of the main ideas of it is the fundamental counting principle. All right, so the fundamental counting principle is using multiplication to find the total number of ways an event can occur. So you're going to use multiplication to find the number of ways an event can occur. Okay, so the first idea would be, all right, so what if I have, I don't know, let's say I'm trying to find an outfit, so I want to know how many outfits. And I have 3 colors of pants. And 2 colors of shirts. And I could have listed each one like black, red, blue, however. Either way, or you could have just been told there's 3 of one, 2 of the other. And so the fundamental counting principle allows us to multiply the number of choices together to get the total outfits. But I'm going to show you what this would look like in a tree diagram so that you can see how to use a tree, because a tree is really helpful with a lot of probabilities when you just can't think what you should do. A tree is super helpful. So let's think color 1, color 2, color 3 of our pants. Okay, so these would all be pants. I could choose any of those pants, and then next I have the choice of a shirt, and I have 2 choices for those shirts no matter what pant I choose. So I could have pant 1 with shirt 2, I could have pant 2 with shirt 1, and you see. So total number of outfits is the last row. 1, 2, 3, 4, 5, 6. So there's 6 outfits. And again, we could use the counting principle that says, well, we had 3 choices, then 2 choices, so we have 6 total. But I wanted you to see the tree diagram. Now, a tree isn't going to work very well when I say I have 3 letters followed by 3 numbers on a license plate. How many different license plates can I make? So I didn't write that part out, but you get it. So 3 letters followed by 3 numbers on a license plate. Well, I don't want to do this because how many different letters will there be? 26, right? So I don't want 26 branches. So that's why we have to have this other way to kind of figure out how many possibilities. So there's 3 letters, so we know that that would be 26 times 26 times 26. And we're followed by 3 numbers. So we can put 0 through 9, the digits. So there's 10 digits that we could put on each one, and we have 3 of those. So multiplying all of these together is how many license plates I can make with 3 letters, excuse me, followed by 3 numbers. And that works out to be 17,576,000. Wish that was my money in my bank account. So that's how many license plates I can make by using just 3 letters and 3 numbers. And I can repeat any of them. So I can have AAA 111 or so forth. Doesn't matter. It does change it if they were more strict. If they were being more strict and they say they want all different letters and numbers, like no repeating, then you'd have 26 choices for the first one, 25 choices for the next one because you would have used one of the letters, and then 24. And then the numbers down here would have done the same thing, 10, 9, 8. And so you would have less license plates that you could make because you're being restrictive. Okay, so let's go into permutations. So permutations is really similar to the counting principle here. Permutations is an arrangement of items in a particular order. So you have to be very careful with the order. Oops. Permutations is an arrangement of items in a particular order. Okay, whereas combinations are not in a particular order. Order doesn't matter. So we have these two different things where one the order matters, one that doesn't. Both of them have a formula you could use to figure out the different number of items that you can have. So permutations, this formula looks like this. NP R equals N factorial, which I better explain a factorial, N minus R factorial, and this one's a permutations. N is going to be the set, the total set, and R is going to be the number of items that you choose from that set. So I might have 26 letters and I want to choose 3. So that's kind of how we say it. So we have 26 letters and you'd have the 3 here. Combinations is written the same but with a C, but the formula is different. It is N factorial over 3, oops, not 3, R factorial. I was like, that's not right. R factorial times N minus R factorial. Okay, so now let's go through, now this is our combinations formula. And let's go through examples of both and when I would choose one, when I would choose the other, and also what is a factorial and how in the world do I use it? So a factorial is, let's do the nth factorial here, just an n. It is like the first one, n, and then you're going to times it by the next one, so it'd be n minus 1, times the next one all the way down to 3, 2, 1. So that's it in factorial. This would be in like an equation form, kind of explaining what it looks like. But let's look at an example. What if I have 4 factorial? What it's saying is you take the number 4 times 3 times 2 times 1. You count down 1 each time, and that's our factorial. So it's kind of like what we were looking at with those license plates where you count down, but you have this key on the calculator that'll do part of it for you. So if I had 10 factorial and I wanted to divide it by 5 factorial, you have to be careful. You can't divide those numbers. You think of it this way. You have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and on the bottom I would have 5, 4, 3, 2, 1. So can you see that these would cancel and you'd be left with 10 times 9 times 8 times 7 times 6, and that would be your final answer on that one, which I didn't calculate the top one either. Top one should be 24, but this one's going to be a lot bigger. Okay, so 10 times 9 times 8 times 7 times 6 is 30,240. This one ends up being 24. All right, so you can find the answers that way, but be careful with the division. And that's why I'm showing you this, because you'll end up with that in those formulas for permutations and combinations. So let's look at another example here. Let's see. So how many ways are there to arrange 8 shirts on a hanger in a closet? So how many ways to hang 8 shirts in in a closet, on a hanger in the closet? Okay, so they want you, well, this one really is, well, you have 8 choices for the first one: 7, 6, 5, 4, 3, 2, 1. So you really don't probably need the formula necessarily for this one, because it's permutation, so it's a little easier. But I want us to use the formula as well. So we can kind of think, well, there's 8 ways: times 7, times 6, times 5, times 4, times 3, times 2, times 1. Or it could be 8 factorial. And let me show you where to find that factorial on a TI calculator. So I want 8 factorial, so I'm going to hit 8, and then I'm going to hit math, and over here at PRB is probability, and actually notice the NPR and NCR. Those are the formulas for permutations and combinations as well. We're going to go down to 4. That's our factorial, and click, and ta-da! It multiplied those for us so that we don't have to put in all the numbers. So there's 40,320 ways to put 8 shirts in a closet. Doesn't that sound like a lot? Okay, so then the next thing, I want us to use that formula. So we have well, it's really 8, choose 8, right? We're for permutations, order matters, right? But 8, choose 8, because we're choosing all 8. We're putting in all 8 things. We didn't minimize it at all. So we would have 8 factorial for the formula over n, which is the same. N and r are the same, so it'd be 8 minus 8 factorial. So 8 minus 8 is 0, so this is 0 factorial. And so we end up with just, well, we can't divide by, I wonder if it gives us an error. I was like, 0 factorial. I guess I didn't, I was like, wait, I can't divide by 0 to get the 8 factorial. Nope, that equals 1. Phew. Okay, so this 8 factorial over 1, which is 8 factorial, which is the same as the 40,320. Okay, that threw me off for a sec, because I was thinking, that's, I don't know, 0 factorial is actually 1. I put it in the calculator to see what they gave me. So we're okay with this dividing by 0. All right, let's put in 8, choose 8 with permutations on the calculator. The way that you do that is you hit 8, whatever your n is first. Then you have to go to math, over to probability, down to, we want a permutation, and then we choose 8. So you're saying 8 for the n, permutation, r for the n, and then enter. Ta-da! So 8, choose 8 on the permutations. Okay, and that's kind of how you use the formula. Let's do another one. What if I just wrote it as 8 permutation, choose 3. So I only want to choose 3. I have 8 items, but I only want to choose 3 from that. So it could be an example of 8 people, and I want to choose a president, vice president kind of thing. Order matters, because I want a president, a vice president, maybe a secretary or something. So order still matters for the permutations, and that's an example of what you'd see. So the formula says n. Remember, it goes n, r. So n is your total. So we would have 8 factorial over 8 minus 3 factorial. So let's simplify this. 8 factorial over 5 factorial. So if you think 8 times 7 times 6 times, and then it'd be 5 factorial for the end, right? 5 factorial. So these would cancel, and you'd have 8 times 7 times 6, which is 336 total ways to pick those. Okay, that's a lot of people or a lot of ways. Okay, and you could also look at it. 8 times 7 times 6. You could have thought that through without the formula with permutations. Combinations, not as easy to not use the formula. So it's kind of a couple ways you could really think this through. So let's put that in our calculator, make sure we get the same answer. We'd hit 8, math, go over to probability, enter, and hit 3, enter. Oops, I picked the wrong one. I was like, whoops, 8, math, probability. All right, 8, choose 3, 336. Remember, that's in the math function. Okay, and even the lower level TI calculators do it really similar and have this function. And you may even have it on your basic calculators. All right, so let's look at something where order doesn't matter, a combination. Maybe we'll just do a combination first. What if I want the same thing, 8 combination 3? What if order doesn't matter, and I have 8 and I want to choose 3? What's it going to look like? Well, the formula says you would have 8 factorial over 3 factorial times 8 minus 3 factorial. So the difference is being divided by the r factorial. So our difference is very small. It's being divided by that. So it's going to divide it into more pieces or make the number smaller. So you have less options when order does not matter. Okay? So if we figured this out, we could think, all right, so we'd have 8 times 7 times 6 times 5 times 4, 3 times 2 times 1. You could do this on your calculator, but I kind of like showing you. 3 times 2 times 1 times 8 minus 3 is 5, so we'd have 5 times 4 times 3 times 2 times 1. So we can see that these ones all cancel. And however you want to think of this, I think, well, 3 times 2 is 6. So this one would cancel with both of these, and the 1 doesn't really matter. So I end up with 8 times 7, which is 56. So it's a lot less options with a combination versus a permutation. So those are the same thing. And that's found in the same place on the calculator. So you'd hit 8, math, go over to probability, but this time go to combination, choose 3. You get 56. Oops, I didn't put it where you can see it. So you go 8, hit 8, go to math, go over to probability, go down to the C, and then you'll find it. 8, choose 3. All right, so what if I asked how many different teams of 11 players can be chosen from a soccer team of 16? That's my last example. So how many, maybe I'll just, how many different teams of 11 players can be chosen from a soccer team of 16? So you have 16 on the team and you want to choose 11. Does it order matter when you're choosing for a soccer team? No, order doesn't matter. So we're going to be a combination. And so how would I do a combination for this one? It would be a total of 16, and you would choose 11 from that. So you can put that in your calculator or calculate it out with our formula. Okay, and so let's see what that one gives us. So I'm going to hit 16 at math, probability, combination, and I want to choose 11 people. I have 4,368 ways that I can choose those people. That's a lot. All right. So that's kind of how you're working through this. So a lot of your problems are written just like this, just combination or permutation. Some of them will ask, so which one should you use? So always look for, well, does order matter? Yes or no kind of thing. And kind of some problems on just using a factorial. So good luck. Let me know if you need help.